Suppose Inga plans to invest $190 every month into some kind of fund. If the fund generates an overall rate of return of 6% compounded monthly, what's going to be Inga's investment worth after 8.5 years? Let's begin by noticing that this is going to be an annuity because we do have a recurring payment of $190 every month. Next, we want to go to our interest rate, 6% compounded monthly. So the frequency of the compounding matches up with the frequency of the payment size. It's a simple annuity. If we assume that the payment of $190 happens at the end of every month, that's going to turn this into an ordinary simple kind of annuity, and the following future value formula should apply. So let's begin by inputting some of the values that we know into our formula. For example, we know our payment size is $190. We next go to I. I is 6% compounded monthly, so 0.06 over 12. The last thing we need is N. We know our frequency number here for the payments is monthly, so 12. And we're going to be going through an investment term of 8.5 years. So let's take 8.5, multiply by 12. That's going to give us the value of N to be 102. Just like we've done previously, I'm going to work on the numerator of our fraction first, starting with our open bracket 1 plus 6% compounded monthly. I'm going to close that bracket, raise that to the power of 102, and then subtract 1. Okay, hitting the equal button, I now have a decimal number that represents the numerator of our fraction. We need to divide by 0.06 over 12. So I've made sure to put an extra set of brackets here in the denominator so that I can program this into the calculator properly. Let's go divide, open bracket, 0.06 over 12, and close that bracket. Hitting the equal button here, we should now have a number that represents this fraction simplified. We still need to multiply that by 190, so let's go ahead and do that next. And that's going to give us a future value of $25,200.70.